A cosmic spectacle is unfolding as we speak, captivating astronomers worldwide. Betelgeuse, the mesmerizing red supergiant that adorns Orion's shoulder, is undergoing a remarkable metamorphosis. This celestial giant, known for its brilliant red hue, has been a cornerstone of the winter sky for millennia, drawing the awe and wonder of stargazers from ancient civilizations to modern astronomers. What makes this transformation so extraordinary is not just the changes occurring within the star itself, but the sheer scale and rapidity with which they are happening. This massive star, hundreds of times larger than our Sun, is showing us just how dynamic and unpredictable the universe can be. Betelgeuse luminosity, the radiant glow that defines its celestial presence, has surged beyond its customary brilliance by an astounding 50%. Imagine a light bulb suddenly burning twice as bright, casting its glow further and with greater intensity. That's what's happening with Betelgeuse on a cosmic scale. At the dawn of this year, Betelgeuse proudly held the illustrious title of the 10th brightest star gracing our nocturnal canvas. Its steady, familiar light was a constant in the night sky, a beacon of stability. However, this unexpected celestial glow-up has propelled it to a prestigious new position, now shining brightly as the 7th star in our awe-inspiring night sky. This leap in brightness has sparked excitement and curiosity within the astronomical community, prompting new observations and studies to understand the mechanisms driving this dramatic change. Betelgeuse, a massive star in its late stages of life, is of immense size. Its dimensions are so vast that if it were positioned at the center of our solar system, it would extend as far as Jupiter's orbit. Eventually, this star will undergo a collapse resulting in a powerful supernova explosion, which may lead to the formation of either a neutron star or a black hole. The anticipation surrounding Betelgeuse Supernova stems from the fact that it will be an extraordinary event. Positioned roughly 650 light-years away, humanity finds itself in an optimal location to witness this cosmic spectacle firsthand. When the stellar explosion occurs, it will produce a breathtaking display of light. Initially, there will be an abrupt influx of neutrinos that will sweep across the Earth, detectable by observatories worldwide. Following this, as high-energy photons escape from the expanding cloud of stellar debris, Betelgeuse will rapidly intensify in brightness over the course of a week, reaching up to 100,000 times its usual luminosity. Depending on the explosion's power, this celestial beacon could rival the brilliance of a full moon and might even be visible during daylight hours, casting distinct shadows at night. This magnificent event will persist for an extended period, offering astronomers an unparalleled opportunity for detailed observations and potentially groundbreaking discoveries. While the supernova of Betelgeuse may trigger speculation and apprehension due to historical associations of such events with ill omens, we can take solace in the fact that we are safely situated at a considerable distance, shielded from any detrimental effects. To fully comprehend the enigma surrounding Betelgeuse, it is crucial to revisit the end of 2019 when peculiar phenomena began to manifest. During this period, the red supergiant star started experiencing significant dimming, a change noticeable even to the naked eye. Observations using the Very Large Telescope in the optical spectrum revealed that Betelgeuse appeared roughly symmetrical, but its photospheric layers exhibited signs of substantial disturbance within our line of sight. The photosphere represents the outer layer of the star where light is emitted. Researchers also detected an expansion of the photosphere, giving the impression that the star was swelling when viewed from Earth. This expansion continued at a constant rate of approximately 8 km per second for most of the year until mid-November 2019, at which point the outward velocity began to decline. By mid-November 2019, the flow of material from Betelgeuse ceased, prompting astronomers to capture new optical images of the star. Their observations revealed two surprising irregularities. Firstly, a darkened region appeared in the star's southern hemisphere, creating a striking contrast with a previous image taken at the beginning of the year. Secondly, the surface temperature of the star experienced a dip, dropping by approximately 80 Kelvin. Between January 27 and February 13, 2020, the brightness of Betelgeuse reached an unprecedented low, approximately a year after the cessation of the outflow. However, the star gradually regained its brightness over the following months, eventually returning to its normal magnitude. This led to the question, what had truly happened with Betelgeuse? All the available evidence strongly suggested that Betelgeuse had undergone an immense and unprecedented event known as a surface mass ejection, SMME. This phenomenon bears similarities to coronal mass ejections, CMEs, observed on the Sun. To better comprehend an SMME, imagine a volcanic eruption on a scale matching that of a star. Material from the star's interior surges upward and outwards, causing shock waves within its atmosphere. Over time, this material forms molecules and dust, partially obstructing our view of the star and causing it to appear dimmer. In the case of Betelgeuse, the SMME resulted in the ejection of a mass 400 billion times greater than what is typically observed during similar events on other stars or CMEs. This amounted to multiple times the mass of the Moon, propelled at astonishing speeds. Researchers noted that such an enormous mass ejection from a star's surface had never been witnessed before. The event allowed for the direct observation and examination of surface details using the Hubble telescope, offering a real-time glimpse into the aging and evolution of a dying star. The SMME had a profound impact on Betelgeuse, causing it to lose a significant amount of mass in a single event. This occurrence demonstrated that a dying star can experience substantial mass loss beyond its regular annual decrease due to stellar wind.
In motion and mixing. As this hot bubble ascended and broke through the star's surface, it triggered the ejection of stellar material. Interestingly, it also disrupted the star's regular pulsation pattern. The star's surface continued to expand while its deeper regions contracted, causing the star to transition from its customary 400-day pulsation to a new 200-day pulsation. Astronomers anticipate that the star's regular motions will gradually stabilize the unusual pulsation over the next 5 to 10 years, ultimately restoring Betelgeuse to its normal 400-day pulsation. Regarding the possibility of a Betelgeuse supernova, astronomers speculate that it could occur at any time within the next 10,000 to 100,000 years. Based on factors such as the star's color, brightness, size, and estimated age, scientists suggest that Betelgeuse is currently in the early stages of helium-to-carbon fusion. This process must continue through oxygen, silicon, and finally iron before the star's core collapses under its own gravitational pull, leading to a cataclysmic explosion. Since Betelgeuse is located 650 light-years away, any supernova event happening at present would only become visible to us after 650 years due to the limitations imposed by the speed of light. Therefore, it is highly unlikely that we will witness the star's dramatic demise during our lifetime. The unique thing about Betelgeuse is that we can actually see its surface, which isn't the case for most other stars. This gives us an incredible opportunity to learn about how big stars like Betelgeuse behave as they get older, including these kinds of surprising mass ejection events. Recently, astronomers made a bone-chilling discovery. For the first time ever, they observed a star eat its own planet 12,000 light-years away in the constellation Ayla. Betelgeuse, with its intriguing name and prominent position in the night sky, has captivated the human imagination for centuries. Its significance extends beyond scientific knowledge as it has left its mark on pop culture and mythology around the world. Betelgeuse has a rich and diverse origin rooted in the Arabic language. Initially interpreted as the armpit of the giant, some scholars argue that it may represent a hand or shoulder instead. This anatomical association is reflected in various interpretations of Betelgeuse, often linked to anthropomorphic or animal figures across different cultures and mythologies. Betelgeuse carries multifaceted meanings and symbolism. In ancient Japan, it represented a severed limb, while in Brazil it was perceived as a turtle's leg or a caiman's hind leg. The Sanskrit term for Betelgeuse translates to the moist one, tied to Hindu astrology's Ardra lunar house and associated with the tempestuous storm god Rudra. Throughout history, Betelgeuse has played a significant role in cultural practices and traditions. For instance, in Macedonian tradition, it symbolized domesticated animals, specifically the cow, and served as a harbinger of warmer weather during the winter months. Similarly, the Inuit people identified it with a ceremonial initiation belt, and the Aboriginal people of Australia associated it with a red kangaroo. In terms of navigation, Betelgeuse has been a prominent reference point for various cultures. Native Hawaiians regarded it as one of their bright guiding stars in their maritime traditions. Additionally, the celestial giant has found its place in modern popular culture, including literature, films, and music. For example, Betelgeuse has inspired the eponymous character in Tim Burton's 1988 movie Beetlejuice and its subsequent adaptations in different media formats. Furthermore, Betelgeuse has left its mark in science fiction, with author Paul Anderson naming one of his characters after the star. This highlights the lasting influence of this celestial marvel in both scientific and creative domains.